So we'll start our presentation today. I'm going to skip a lot of the marketing fluff that you typically see in most demonstrations and presentations. I'm going to jump right into it. We're going to be talking primarily today around Azure's OpenAI and Amazon's AWS Textract. These are the two tools that I'm very familiar with that offer generative AI. And in this case, we're not using something like Microsoft AI Document Intelligence or Google Document AI. Here, we're going to be issuing query prompts to extract certain information from unstructured documents. So this is going to be ideal for things like contracts, mortgage lending documents, financial services documents, things that don't have key value pairs, right? So key value pairs, you have a label like bank name, and then you have a value. That's where you'd want to use something like an AI document intelligence or your general extraction profiles. Now, one of the hard things with generative AI, specifically Azure's OpenAI, is the licensing model, which is difficult to understand. So we're going to quickly talk about the commercials associated with the pricing. So when we work with things like OpenAI and AWS, there is no interface. We're going to show you how you build an Azure OpenAI Studio connector, but then how do you access it? How do you send it a document, and how do you get JSON or some extraction data back? So I will say that this is a little bit of a technical demonstration presentation. So today we're going to be introducing Kodak Alaris's info input. It's basically a batch capture, document capture software application that wraps around all these engines that you see in the bottom right. Now, this is just an interface to be able to use the intelligence of Azure OpenAI and those types of things. So if you're saying, hey, how do I get this tool? I'll thank Peter Klentos and the Kodak Alaris team for providing some of the demo harness stuff I have today. And hopefully it will resonate with you guys in terms of what you can do. So let's just talk a little bit about what does it cost to consume Azure OpenAI. So OpenAI is essentially ChatGPT. So we're going to talk specifically about the 4.0 and 4.0 mini models. Okay, so those are the typical two GA general availability models available through OpenAI and through the Azure AI Studio. Now, the way they charge is on input and output tokens. So I gave a quick example here. So essentially, 4 characters of a word is 1 token. Okay, and so you can see the cost per token. There's inputs, which are, as you can see here, for the 4.0 model is 0.00406 cents per input or token, and then for output is 0.01218. So if we just took a typical page, 812 tokens, which means that there's 4 characters per token. That means that there's around 3,200 characters per page. That would cost you for the 4.0 model 0.01624. And if you were to use the mini model, which is the one we're going to use in the demonstration, you can see it costs 0.00061 cents per page. So the reality is, if you extract a whole text page, it's about 93% less expensive to consume Azure OpenAI than it is Azure's AI Document Intelligence and some of these other extraction utilities that are out there. Okay, now when you look at Textract, it's quite a bit different. So most of these hypervisor OCR engines utilize this concept of a per page charge, right? So in Textract's costs, it's actually 0.015 per page. So the difference is trying to figure out what it's going to cost you to consume Azure OpenAI is very difficult, but at the same point in time, compared to AWS Textract, it's 96% less expensive. So the reality is Azure OpenAI is a really good tool used in the right use cases, which I'm going to show several today. But does this make sense for your transactional documents, things like invoices and bills of lading and packing slips and all those? The reality is depending on how we handle tables and whether that's a requirement, I would say yes. And I have an article coming out in Intelligent Document Processing Community on LinkedIn that will highlight a lot of what you're seeing here in a lot more detail. All right, so let's now configure an Azure OpenAI connector and actually have and feed it some documents and see what that looks like. And then I'm going to give you a demonstration on using Kodak's wrapper around it and how we're issuing query prompts to it. So again, first is let's just create one. It's not hard to do. You do have to have an Azure subscription. Again, it's a very low cost. And so you're going to see a few things here when we go to configure this. One is that you have to adjust the content filter. So depending on the type of documents you're processing, you might have to address the content filter. So if it's looking at keywords and some of those words are maybe prohibited or have a slant to a particular content, then you're going to have to use the default content filter, and you'll again play around with the tokens. But not hard to set up, and we're going to do that. Followed by we're going to set up AWS Textract. So there's two ways to consume this. You're going to see using Kodak, we can do what we call, or what I define as an autonomous process. So we're just going to get an API key to AWS Textract, and we're going to send it query prompts like, what is the transaction date, and see what it extracts. Now you can also build adapters. So I'm going to show that concept as well. So it's a much different approach. Now, when we configure the Kodak solution, you're going to see there's an interface to provide those query prompts. So you really only need one Textract API connection to be able to issue literally whatever you want. So you don't have to create models for each document. Okay, so let's dive into this. And so the first thing I'm going to do, let's go into, oh geez. Move this bar over here, and we're going to go into, so this is Azure Studio. Okay, so if you come in here, you'll notice there's Azure OpenAI, and then there's the Azure AI Studio. So in our case, you can start here or in Studio. You could build it in both locations, but as you notice here, I've already created one. But to create one, you just hit create, and then you pick, in this particular case, the subscription, the resource group. So I created like a generic resource group. This is kind of your security group and who's going to have access and can build models and such. I always use East US. You can use East 2. It really doesn't matter, but obviously there's regions all over the world. Give it a name. And then the pricing tier, you're going to use the standard pricing tier. And that's it. That's literally it. Now you can tag... Zardes. Okay, so as you see here, now I can basically, is this available? I could tag it to a resource, all those kinds of things. But ultimately, I've created one, and you can see here, PIF Azure OpenAI, and I can open that up. And this is where you're going to get your API keys and all those things that we need. But one of them is this, you're going to see here the ability to actually go into the ability to actually get into the studio piece. So there's not much to do here, but within the studio, you could see we can create a project, and we'll create this. Azure Studio up. It looks like they changed some prompts around. So explore Azure Portal Foundry, and then this is where we can actually send a document. So let's just take a document here, and we're going to use a couple sample documents here. So we're going to use for OpenAI, let's use the Bailey letter. Okay, and we'll just send this JPEG, and we're going to ask, what is the loan amount? Question mark, and then hit enter, and then you're going to see using the chat prompt that it will return a result. Now that's great, but I'm not going to be able to give access to people and have them come in here. I need to be able to send this document and get this text output returned. And I'm going to show you the different ways to do that. But ultimately, once we create that particular Azure OpenAI connector, you'll go to deployments here, and you'll see here's the deployed model. And you'll notice here two things: the target URL and the key. That's the only two things you're going to need. Okay. And then again, you can now issue as many query prompts as you'd like. But as you saw there with the chat playground, so to speak, you can basically upload and test using that particular model. And again, I'm using the 4.0 mini model. They do have the 1.0 model out, which is called Strawberry, which has some reasoning logic in there too, but that's at a significant cost. So this works really well for us. Okay, so that's how you set up Azure OpenAI. What we're going to do now is go to AWS Textract and do the same thing. Okay, so you'll notice when you go to Textract now, you'll see this custom queries object here. Now, I've already created an adapter. You can obviously hit create adapter here, but I'm going to just go through the sequence, and you'll notice here it has like step 1 through 6. So data set, queries, and then you verify your documents. So data set is you basically upload a bunch of documents, okay? So typically there's a few different ways to do that. One, you can add documents here, and it will prompt you, or you can add them to an S3 bucket where you can pull in those particular document sets. Okay, now it will say start reviewing, so you're going to start annotating those particular documents. So let's now look at the queries that I wanted to create, and these queries can be whatever you want. What was the date? What date was the letter sent? Who is the borrower? What is the phone number for the bank? What is the account number? Now you don't have to structure it exactly in a question. You could just put account number, right? Or borrower name. You don't have to do in a query, in a query kind of syntax. But you'll notice here now I can verify the documents, and one of the documents I'm just going to pull up. I'm going to show what it does. So if I select it and then view annotations, you're going to notice here is a fake we call Bailey letter, and what was the date the letter was sent. And you notice how there really isn't a key value pair here. It was able to figure that out. Who was the borrower name? Carrie Shirley. What was the phone number? What was the account number? What was the ABA routing number? Who was it attention to? So the benefit of this is, again, you're using standard query prompts to be able to extract information. And the nice part is you can make it somewhat generic so that it can pull data across a number of different document types. Like, what is the transaction date? What was the date on the document? Those types of things are very generic, so it would work likely on any type of document. Okay, so now we have basically, you'll see here an AWS setup, an adapter. Now, you don't have to build the adapter to be able to issue query prompts to it. So we're going to show how we actually set this up. So I have Kodak info input here. So the first thing I did was I created an extraction profile, and this is for the AWS piece. So you'll see here, AWS Textract and analysis is their essential, like, generic form parser. Okay, and you'll notice there's a query checkbox here, so I can do things like your generic, intelligent document processing, where it's looking for key value pairs and things like that, or I can use a query, and that's how we build that here. And then if I go into the jobs. So one of the, I'll just say this accident claim, I just consume the extraction profile I just set up. So you'll see here in the dropdown is that Amazon text extract analysis. And one of the queries, or one of the options here, is this ability to set queries. Okay, so these are the queries that we're going to be passing to that AWS Textract. And then we just need to map it to what we call a document class. So whatever the file number that we extract, put that in this file number field here. And the benefit of Kodak is then I'm able to export this information, right? And there's a whole interface to be able to support that. So let's take a quick look here, and we'll run a couple scenarios through. So I'm going to come into our web-based interface here. We're going to capture. Let's start with the AWS stuff. So we'll do an accident claim. And so we can monitor a folder, we can browse out, as you're seeing here, that's what I'm doing. So this is an accident claim. So I'll select the accident. Okay, and you'll see it's going to bring open that particular document. We'll just close the batch, let that go in, and let's grab our next batch. And this one is using claims demand letter. So in this case, we're using handwritten letter. So both handwriting, different languages, all of that's supported, but this is a handwritten paper claim. So as you can see here, handwritten, there's all sorts of information. It's 2 pages. This generative AI is using NLP, which is natural language processing techniques, to figure out the context of the letter, right? So here we're going to be issuing query prompts against that. So process that. We're going to do all 4. I'm just going to quickly capture all 4 of the Textracts. Here we're doing a pay stub. The nice part about this is you're going to notice there's columns of information. Okay, so on something like this, you notice there's hours, rate, current, year to date. You have these labels like net pay here at the bottom. So I can initiate what is the net pay year to date? And it should be smart enough to know to pick the year to date column associated with that net pay, right? Or it should be. So we'll process that. And then the last one is our utility bills. Now, this is a cool one. I guess the best approach here would be more so from a, like when you want to look for kilowatt used, or if it's a water bill, gallons used, things like that. You're going to notice there's these kind of kilowatt hour. So one of the query prompts is how much did we use in terms of, and you have to structure it just right so it knows what to extract, but how many kilowatt hours did we use? But sometimes it's sewer bill, sometimes it's a water bill, and it's not always kilowatt hours. So you have to have a query prompt that's good enough to be able to extract that information. Okay, so we've sent all of those in. You'll notice created today. We have, so we'll start with the accident claim. This is the one that just came back. And when we look at it, this one's a little easier, again, because there are some key value pairs here. But as you notice, file number, claimant, again, these are all key value pairs. So you can certainly use this with your, intelligent document processing, your extraction models. But again, based on price, Azure OpenAI is less expensive than AWS, and Azure OpenAI is less expensive than the other Textract-like tools. Okay, so it came in no problem, and it was able to extract all the information, regardless of really the label, right? So here we have claim AMT, not amount, but Textract understands AMT as amount, right? So that's where that NLP, that natural language processing, comes in. It's really flexible to be able to handle those different synonym type matching against a label or a key. All right, so let's now look at the next one. We have the claims demand letter. I think this is one of the cooler ones. Okay, so if we move this over one, you'll notice we're using a advanced indexing form, so you can customize this right side. But in this case, we're doing 2 things. One, we're grabbing the policy number, and then we're doing a database lookup to get the claim number. So that's this claim number you notice actually was populated from a database. It also looks at the sentiment, right? So you see this high priority. The generative AI within AWS can actually read sentiment, right? Is this a negative letter? Is it a positive letter? Is this, the house is burning down? It's very important. So we can actually, route based on a priority level, based on the status that's associated with the sentiment within a letter. Here, what was the date of the accident? So it was smart enough not to pull that top left date, right? January 25th, 2023. It knew the context December 18th. On December 18th, my grandson and I were involved in an accident. So it was smart enough to figure that out. Here, was an ambulance required? So it, you know, you could give true false type statements to figure out, again, downstream workflow. Maybe this gets routed with a higher priority. How quickly they want this settled. Is there a mention of settling quickly? Is there a request for next steps? Things like that. And then you can see here, is there a mention of an attorney? Do they ask for a response back? So a lot of these things can then trigger downstream workflows, and a real benefit to IDP, intelligent document processing, and likely the generative AI is that we're extracting and normalizing data from unstructured documents. This is a completely unstructured document. You don't know what it is, right? And then being able to do this in the past, like 2 years ago, you couldn't do this. You would have to create some level of regex where you would have to look in the content for a date, but then you wouldn't even know if that date was related to the accident. You just know that it's a date. So really that NLP and the ability to contextualize what we're reading here and then actually use that in extraction is really the benefit and where we've come. Now you can see here what is the claimant's name? So it picked that out. Who wrote the letter? You picked that out. So pretty cool. It was able to really figure out from this handwritten letter, contextual information, which is great for mailroom type situations, lending, mortgage situations. It's endless what you can do with this. Okay. So let's now go to our pay stub example here. Again, the pay stub, what is the pay date? Not hard because that stuff's really here. Who's the employee? Now, again, there is no employee name here. Not really sure how it does that. I think what it does is it allows us to basically contextualize that Carl Anderson, that sounds like a name, right? So it's figuring out what the name of the employees. Likely there's nothing else here. It does show Carl Anderson down here, but I think in the context of this area, which has the address, social, date of birth, it likely deinterlaced the data and figured out that Carl is like a name. And again, I don't know the inner workings of their large language model, but that's clearly what's happening here. Here, again, employee address. There is no label that says, oh, this is an address, but likely the format of a typical U.S. address looks like this, and it was able to extract versus the address down here, right, where it exists on the page also is how it contextualizes that information. What's the gross pay? In this particular case, it used the current. What is the net pay? Now, in this particular case, you notice how current, it grabbed the gross pay from the current versus the net pay from the year to date. So if we look at what that query was on the back end, you're going to notice I actually asked it. So we go to the queries here. What is the year to date net pay, right? Versus what is the current gross pay? So that column, it was current and year to date. So it was able to figure out what that column meant as it relates to net pay. So current versus year to date. So again, if you can, and it's called query or a prompt engineering. It's like a whole new kind of avenue. It's a role now in most organizations and how you can issue the right language to extract the right information. So that's important when you look at that. Okay, and then the utility bill. So here we were able to, what is the usage? So it was able to pull the usage from this particular area. So kilowatts used, right? That doesn't say usage. Oh, it actually says electronic usage history, right? And then it was able to figure out the vendor name, the customer's address. Again, customer's address, right? So how does it figure that out? It likely knew that this was the name of the customer, and then that was the address, and then the account number. And as you can see there, so the benefit here is in a typical, if you're using those neural networks that you've been seeing us talk about a long time, trying to extract usage would be very difficult to do. So that's where the generative AI piece and some of these kind of ancillary words that make up, a query string. So if we look at that, let's take a look at the actual query. What is the usage or gallons used? Okay, so what I was doing there is in the situation where there might be water or sewer, it's not going to be kilowatt. It might not even be usage. It could be gallons. So we're able to also use that query prompt to for other utility bill scenarios that might not have the word usage in it. Okay. All right. So those are the AWS query prompts. Now, what I wanted to do is look at a few different Azure OpenAI. I think, and again, Azure OpenAI is a lot less expensive. It's using the ChatGPT 4.0 engine mini model. Now, the mini model is a small language model, right? So, why is it less expensive to consume? Because it's not as feature rich as the 4.0 large language model. It's a mini model. So what they've done is ratcheted it down so it's more efficient on electricity and processing costs, and that's why it's less expensive to use. So you're seeing that now. You saw that with 3.5 mini. The GPT engine, every time it seems to release a new version, there's a mini version that comes along with it. All right, so let's take a look here. We're going to capture now our Azure. This one, we're using the Bailey letters. So again, these Bailey letters are unstructured letters that you get when a bank sells to another bank or lending institution, and you don't know what you're going to get, right? So if bank XYZ sends you a letter, you don't know what the format of that letter is. You just have to accept this as it comes. So naturally, they're very unstructured. So if I come in here and I grab our samples demo, and I have a couple Bailey letters here, so I created some fake ones. So I'll grab two different documents, two different scenarios. They look and feel different. You can see here a lot of the information is not key value pairs. So something like ABA, you're seeing kind of that ABA and then the number and account. So from that perspective, it is. But at the same point in time, a lot of the stuff's unstructured, right? So what's the bank name? Well, it's probably Georgia Bank and Trust, but it doesn't say bank name, right? So it has to read the context of the words. And again, I just published an article in Workflow magazine in their November edition, which talks about NLP and how the algorithms break down the words to figure out what it's reading. So we'll send that in. And I have two other examples here. This one with the commercial lease. So this is leveraging, we're going to leverage key value pairs using Azure's AI document intelligence, which is a penny a page, to extract a couple key values using a regex expression. And then we're going to use the Azure OpenAI to grab the rest. So this is an example of how we use both to extract from a single document. So you can use this. So if, for instance, Azure OpenAI doesn't do a great job with things like tables, because that's hard for generative AI. You saw like line item extraction. There's already pre-built models on Azure's AI document intelligence and Google Document AI and AWS Textract's expense parser. But in situations where it just can't figure it out, you can use both technologies. So here we have a 12-page commercial lease. Let's send that in. Now I'm going to do the same thing, but this time we're not going to use the key value pair extraction. We're just going to use, and we'll grab this lease agreement here. And so I'll grab this restaurant lease. This is a 21-page. It'll take a few seconds for that to process. Okay, so the first one came through here is the Azure OpenAI Bailey letters. I'm not going to talk a lot about the Kodak interface, but if we look at how we built this, okay, so if we come into our Bailey letters, you're going to notice there's a step in the workflow, okay, called OpenAI. And you're going to see here from our first step in the process, we basically, when we created that OpenAI engine, we have an access point. And so that was in when we create here and you look in the deployments, you're going to see here this target URL and the API key. Those are the two things you need. And then you're going to see here, all I need to do is put the API key in there and put the endpoint in here. And then you'll notice Q1 through 10, and you can put as many query prompts as you want. But these are the actual query prompts that I'm going to be sending to Azure OpenAI. And you notice they're not, some aren't capitalized. It's not a what or a how, and there's no question mark. It doesn't really matter. So you don't have to phrase the question in a question syntax. Okay, so ultimately, what happens here, and I'll show you, this is the example. Here's the OpenAI. Okay, what is the loan number? Okay, so you're going to notice here that's the loan number, the loan number. What is the ABA number? What is the borrower name? So it was able to, if I scroll over here, it was able to look at the name. So you see here the mortgage loan for Michael Smith. Okay, or it found Smith Michael here, but you're noticing the borrower, it found the name within the context of the paragraph. Now, again, depending on how much string of text, that name could be down here on the second line, it could be on the first line, it could be all the way. So using any type of zonal approach or using some sort of a intelligence processor, it's just not going to work well. So the ability to extract that information, you also notice here how it figured out what the loan amount was. Now that could have been done based on the dollar sign, but you see here the loan number associated with the loan amount. Who is the lender? Again, it figured that out here. Date of the transaction, you see here. What is the bank name? Again, using the bank name here. Let's go to the second one. Here, what's the loan amount? Now, in this particular case, it said note amount, not loan. Loan number. Here it just says loan, right? But it figured out that's the loan number. The ABA, who's the borrower? Clear that's a nice, key value pair. Here we have the loan amount. Again, loan amount, it's note amount, not loan amount, but it was able to figure that out. And then what is the lender's, who is the lender? So you can see there, basic lending group, and then the transaction date, and then who is the bank name. So then it figured out that. And again, that was not, there's really no key value pairs. It had to figure out the context for that. Okay, so let's look at the commercial lease. In this case, we're going to be using a key value pair extraction. Okay, so you notice the key value pairs have the ones with the confidence indicators. And when I click on it, it highlights in yellow here. So let's take a look at how we process that particular one. In this particular case, you'll see the first step was we're looking for a regex using the Azure AI document intelligence, not the Azure OpenAI. I know there's like a lot of wordiness there, but they're two really different products. So you see we did street and square feet. And that's how you'll notice that it grabbed this, which is the street address. So it used that word street. And then here at the bottom, the square footage. And then everything in between, lease of the term of the lease, the date of the agreement, the deposit amount, the rent amount, the late fee, what kind of lease is it? The insurance policy, and then a summarization, which is what GenAI is really good at. That's been around for quite a bit, which is you can summarize. You see that kind of all your transcription and all the teams and Zoom and Google, you have all those types of summarization kind of agents now. So in this one 12-page document, it was able to pull out this very important information. And again, these commercial lease agreements can be a way to manage that type of process is important. Okay, and then our last example here, and we're right at 40 minutes, which is great. Our lease agreement here, we have a 21-page document. Again, with a lot of the same, it's the same model, it's the same questions, right? No key value pairs, but as you see, it's totally different agreement, and it's able to extract the right data regardless of what that lease agreement is. So whether it's a lease agreement A or lease agreement B, you can funnel them all into the same model, and it's able to properly extract that information.